All right, here's a proof from section 2.5. It's a little bit more involved than a typical two-step proof. So this one's got a couple more steps. Looking at this problem, you have BAD is congruent to FAD. So anytime you have information in a given, I'm going to mark it in the picture. So BAD is this whole angle is congruent to FAD. Okay. You also have that AD bisects CAE. So that means, I'm going to have to say this, but that means that CAD is congruent to EAD. So I'm trying to prove that BAC, this angle, is congruent to that angle. So let's see what we can do. So I'm going to write the given, BAD congruent to FAD. Ray AD bisects angle CAE. As always, the first step is given. The next step, this is actually only going to be 3 steps. The next step is use the bisector. The fact that AD bisects CAE tells me angle CAD is congruent to angle EAD. And the reason would be if bisector, then in this case, 2 congruent angles. Okay? So that's step 2. And now I'm actually all ready for step 3, which is what I'm trying to prove, the final step. Angle BAC is congruent to angle FAE. Okay? The reason is because I had 2 big angles congruent to start. I subtract out these little angles that are congruent. And you're left with BAC and FAE, so that's your subtraction property. That's very simple. So subtraction property is what you would write. Basically what you did was you took big angles, or you took congruent angles and subtracted them from congruent angles. And what you are left with are congruent differences. That's a subtraction property. So I hope that helps. That was problem number 11 from section 2.5.